Okay, the numerical reads a beam AB 8 meter long has supports at its ends A and B. It carries a point load of 10 kilonewton at 2.5 meter from A and another point load of 7 kilonewton at a distance of 7 meter from A and an uniformly distributed load UDL of 2 kilonewton per meter between these point loads. Draw SFB and BNB for the beam. Also find the maximum bending moment and its location. This is a university question, university exam question. So let us try to solve this. So I have already drawn the beam here based on the question. The diagram is not given. I have drawn it to save the time. So it says it's a 8 meter long beam. So I have drawn a horizontal line. I just change the points. So if you want, let us keep it as it is. So the beam is AB, and let us say I have point loads at C and D, right? Okay. Beam 8 AB 8 meter long has its supports at its ends A and B. So I have one support at A, another support at B, and this total length is 8 meters. Okay. Then it says there is a point load of 10 kilonewton at 2.5 meter from A. So this is A, 2.5 meter away from A is C, where I have a 10 kilonewton load, point load. That's why I'm showing this by an arrow. Then I have another point load of 7 kilonewton at a distance of 7 meter from A. So 7 meter from A, so this is 4.5 plus 2.5 is 5 plus 2 7, right? So from A at 7 meters I have a point load of 7 kilonewton and uniformly distributed load of 2 kilonewton per meter between these 2 points. This is one point load, this is second point load. Between these 2 point loads, I have a UDL. You can see this wavy line here. So this is UDL, and the intensity of this UDL is 2 kilonewton per meter. Now you have to draw the BMD and SFD, and also you have to find the maximum bending moment and where it occurs. Now, the practical example for such kind of cases can be, you can imagine this is the beam on our floor on your apartment building, and this can be the walls, right? So it is uniformly, the floor is having weight, self weight. So because of which you have uniformly distributed load here, and the wall is causing a point load at this point and this point, and these are the two columns which is supporting this entire beam. You can imagine something like this, right? Now let us try to solve this numerical and draw the BMD and SFD. Now, like any other problem, we have to start with finding the support reactions. Now, this is not symmetric. All the problems we had seen so far was symmetric. So, finding this reaction was very easy. You just had to find the total force divided by 2. That would be the reactions if it is symmetric. But now it is not the case. This is a asymmetric numerical. So, we will have to use our conditions for finding the support reactions. Now, for equilibrium, we need two things. One is summation of all the forces acting on this beam is 0. Summation of all the bending moment that is acting on this beam is equal to 0. Now, I will use the first condition. sum of all the forces is equal to 0. So from that I can write like this. Now at point A I have the reaction, so I will call it as RA, and since this is upward force, I'm taking upward positive, downward as negative. So RA will be positive, or if you are getting confused, this is the easiest way. Put all the upward forces on one side, put all the downward forces on the other side.
Hello, sir.
Yes.
Okay, sir. Now your screen is working, sir. It was stuck at a point.
It could be problem with your internet connection. Okay.
Now it's working, sir.
Yeah. Thank you.
No, sir. Your voice was coming, sir.
Fine. So RA is
Thank you.
in upward direction at A, plus RB is also in upward direction. This is my assumption. So it can change also, right? So we will see some numericals where it changes. Now this is equal to, I will put all the downward forces on one side. So I have 10 kilonewton here and 7 kilonewton here. So 10 plus 7 plus I have a uniformly distributed load which is having intensity of 2 kilonewton per meter. Matlab, if you measure 1 meter length, this weight will be equal to 2 kilonewton. So now I have 4.5 meter length UDL. So it will be 2 into 4.5 meters. So plus 2 into 4.5 kilo. I'll just put that in the bracket. So this will be, let me open my calculator. 10 plus 7 plus 2 into 4.5 is 9. So it is 26. 26 kilo Newton. So this is the total force which is acting on this beam in the downward direction, and the support reactions should be proportionate to this, right? So now I'll apply the second condition, that is sum of all the bending moments on this beam will be equal to 0. Now to find the bending moment, we need to use the sign convention. So I had shown the sign convention in a very simple way in the previous classes. I will explain it once again. So what you have to do is you just draw a box like this with 4 cells, and on top you write here left, and this is right, and here you write clockwise, here you write counterclockwise, right? So left side clockwise is positive. You put a plus here. Opposite to that, diagonally, it will be positive. Put another plus here, and remaining two will be negative. Right? Now, using this sign convention, I will find the bending moment at A. Now, how to do that? Okay. So, taking moments about A, Bm A is equal to, I will start from the extreme right end. Now I have RA at this point, and this is in upward direction. This is the pivot point about which I am taking the moment. So RB is moving upward, and because of which it is making a counterclockwise moment, right? So right side counterclockwise is positive. So I will write it as RB into the total distance from here to here. What is the distance? That is 1 plus, and this is 7. So the total distance is 8 meters. Fine. Next, at D, I have a point load 7 kilometers, which is downwards. All these three are downwards. So same kind of sign, whatever I'm going to get now, will be applicable. So this is making a clockwise couple, a clockwise moment about A. So on the right side, clockwise is negative, right? So I will say minus 7. The distance between B and A is also 7 meters. So 7 into 7. Next, come to point C. UDL we will take in the end. At point C, I have another point load which is 10 kilonewton and it is acting downward. So these two are in same direction. So the bending moment will also have same sign. So this is minus, so this will also be minus 10 into the distance is 2.5. Again. Now this UDL that is there between C and D is also a force which is acting in downward direction. So right side downward direction it is making a clockwise moment. So that will also be negative. Now what is the intensity? It is 2 kilonewton per meter. So 2 into 4.5 is the total load of the UDL, right? So I will write like this: 2 into 4.5, that is the total load, and I am assuming that this load is acting at the center of gravity or the midpoint of CD, right? So I am taking moment about A, so I have to write like this: 2.5 plus 4.5 by. Any question on this? How we took the moment?
Can you explain it once?
Okay. See.
Sir, and some students are facing the problem that your voice is coming, but the slide you are showing it's stuck, sir, in their screen.
Oh, really? Let me stop sharing and
So
share.
someone just put in.
Yeah, I'm sharing once again. I don't know.
Okay, sir. Thank you, sir.
If your internet connection is slow, then you may face such problems. Is it visible now? Akshay, Jose,
Yes, sir.
anybody else not able to see the screen now? Everyone can see,
Yes, sir.
right? Let us proceed. So somebody wanted me to explain this once again. So what I'm doing is I'm taking moment at A, point A. Now what is moment? Moment is load into perpendicular distance. We have studied this in engineering mechanics already, right? Now I'm using this sign convention. This is the sign convention everywhere we follow, right? So if you see in the books, they have given very complex methods: left side clockwise, right side this. So many things they have given. So students generally get confused in the sign convention and they draw will down, right? So for this reason, I always teach my students this very simple technique. What I've done, I've drawn a box where I have put four cells like this, and on top I have written left side and right side, and on the left side here I have put clockwise and counterclockwise. Now you have to remember this one thing: left side clockwise is positive, right? So you put a plus mark here. Diagonally opposite you will have plus and other two will be minus. So what it means is, now you take moment at any section. Okay, now let us say I need moment at C. If I consider the force at point A, that is my left side force, this is upward and it will make the beam rotate in clockwise. So left side clockwise is positive. The bending moment caused by this force will be positive. If you take right side, this is my section, this is the right side force, it is acting downwards, so this is making again clockwise movement. So right side clockwise will be negative. Okay, this is the sign convention. Now using the sign convention, I am trying to find the bending moment at point A. Okay, uh, so how to find this? I will start from the extreme right end. Now at extreme right end, I have reaction. I did not write it down here. So I have RB. I don't know the value, and here I have RA. Okay. So RB is the force which is in upward direction, and because of this, it is making a counterclockwise moment. Okay. So with respect to A, B is on the right side. So right side counterclockwise moment, it is positive. So what I did, RB into perpendicular distances, the distance between B and A, that is 8 meters. This length is 8 meters. So I took RB into 8 minus, I have a force of 7 kilonewton at D, which is acting downwards, and this is making a clockwise movement on the right side. So right side clockwise movement is negative. So what I did, minus 7 into the distance is, this is 7 meters. So 7 kilonewton into 7 meters minus, come to point C, I have 10 kilonewton force which is acting downwards. So 10 kilonewton into the distance is 2.5 meters, minus 10 into 2. Now we have the UDL. UDL is per meter force is given, right? So to get the total force, I first multiplied the intensity with the length of UDL, 2 into 4.5. 2 into 4 and I'm assuming this total force to be acting at the midpoint of the UDL. UDL is only between C and D, not on the entire beam, right? So what I did, the midpoint of this is 4.5 by 2 and this is 2.5 meter away from C. So 2.5 plus 4.5 by 2. If you multiply this, this will be the bending moment because of the UDL. Are we okay?
Yes, sir.
Yeah, good. And now this should be equal to 0, right? So that is the criteria. Sum of all the bending moments should be equal to 0. Now, if you solve this, you can find the bending moment, the reaction at RB. Now let us try to solve. See, all these are negative, right? So this is equated to 0. So I can take this on the other side. So what I will do is I'll directly calculate it and put the value there. Let me start from this. 2.5 plus 4.5 by 2 is 4.75 into 9. So this is the bending moment because of UDL, this section, plus, because once this comes on the other side, it becomes plus 10 into 2.5 plus 7 into 7 is 49. So the total bending moment is 116.75 because of these three forces. And I have RB into 8. So I will divide this by 8. So 14.59375. So I will take it as 14.59. So RB is equal to 14.59 kilonewton. All right. Now RA plus RB is 26. So I can find RA easily. RA will be equal to 26 minus 14.59. 26 minus 14.59 is 11.4 kilo. Now I have found the value of the support reaction. Okay, let me just move this a bit. This has become very close. Yeah. Now I will just put the values here. RA is equal to 11.41 kilonewton and RB is equal to 14.59 kilo. Okay, so I have this. Now let us start drawing the shear force diagram. Now if you see the TechMax or technical book, they have given a very complex method. I really don't understand why you have to do that. I don't know if you have seen that book. He mentions just on the left of A, it is this much zero. On the right of A, it is equal to this much. You don't have to do all that drama at all. You just follow this very simple technique that I am going to teach you. What you have to do is start from left end. Always start from this extreme left end. Now at extreme left end, I have the reaction of 11.41 kilonewton. So these are all approximate. You don't have to take a scale like 1 centimeter is equal to this much and try to draw. No, you don't have to do anything like that. You just have to do approximately proportionate drawing. That's all. The shape is more important. Now between A and C, there are no forces acting. So I will draw a horizontal line like this. Fine. Now at point C, there is a 10 kilonewton force which is acting downwards. So you just have to see the arrow direction and you draw the lines following that. Now this is 11.41 and approximately this is 10, right? So I have come down by 10 kilonewton. Now from C to D, I have UDL of 2 kilonewton per meter and the length of the UDL is 4.5 meter, right? So let me open my calc here. This is slightly complex, so I'll show you how to. Now I started from this point, so that was positive 11.41 and I came to this point where I dropped by 10, so minus 10. So I am at 1.41. The value at this point is 1.41. Now for UDL, we have seen in the last numerical, the shear force varies linearly as an inclined line. It will go as a inclined line like this, right? So what is the magnitude? Now at this point, the shear force because of UDL is 0. At this point, the shear force because of UDL will be maximum force or the total force, which is equal to 2 kilonewton into 4.5, that is 9 kilonewton. So at this point, it will be 9 kilonewton downwards, and at this point, it will be 0. So I will just, you don't have to draw like this.
Weh, lalu.
Please mute your mobiles.
Kagak
So I'm doing a construction here for us to understand. I have drawn a horizontal line at this point, and
Utman.
who is this?
Tararara.
Okay. Now I will draw another line at this point. Now this distance is representing the total shear force because of UDL, which is 2 into 4.5, 9 kilonewton. So this is 9 kilonewton. Is that okay? Right? So this distance is representing 9 kilonewton. So what I will do now is I will draw an inclined line starting from this point till here. So this is the variation of shear force for the UDL. Now I have come at this point. Okay. Now from here I have another force which is 7 kilonewton, which is acting downwards. So from here I will draw a straight line. Now this represents me 7 kilonewton. By the way, here let me just write these values. Now here this is 11.41. Now 11.41 minus 10, this is 1.41. 1.41 minus 9 is minus 7.59. Below this line is negative, so I will not write minus explicitly. 7.59. Now 7.59 minus 7.59 minus 7 is minus 14.59. So this is 14.59. Right? Now I'll draw another horizontal line here because between D and B there are no forces. So you draw a horizontal line like this, and at D I have reaction which is equal to 14.59. You see here 14.59 minus 14.59, and at this point it will be positive 14.59. So it will be upward. So this is the shear force diagram for the given numerical. Okay, so you just have to follow this. If you follow the method what I explained properly, always start from the left, or if you want you can start from the right also. You will get a mirror of this diagram. It will be same, you will not get anything different. But to get proper diagram, always start from the left, take upward forces as positive, downward forces as negative, and start from this point. You start with the reaction. This goes up like this, then horizontal, then you come down, then UDL go down like this, then a point load, so it comes down again, and again it is horizontal because there are no forces, and then upward force because of reaction. So this is my shear force diagram, SFD. This here is positive shear force, and here this is negative shear. Any questions or doubts on this? Okay, let us proceed. Now I have to find the bending moment and bending moment diagram. Correct. Now for drawing the bending moment diagram, we have always the bending moment at the ends will be 0, where you have simply supported beam like this and it is an end. If it is a cantilever also, the free end will have 0 bending moment. I explained this earlier. So BMA is equal to BMB is equal to 0. Okay, these 2 points, the bending moment I have already found. Now let us find all other points at C. Now again, another trick is when you are finding the bending moment, some faculty they teach you always take from the left or you always take from the right. I teach my students in a different way. What I say is, now I need to take bending moment about C, correct? So you see on the left side and you see on the right side. On the left side, I have only one reaction, which is RA. And on the right side, I have a UDL, I have a point force, I have a reaction. There are three forces. So which is lesser? Left side is having less force. So for taking moment about C, you have to consider left side. Now if you come to D, on the right side there is only one reaction. Left side we have so many. So for finding the BM at D, we consider the right side. Like that, you have to see the condition and accordingly find the bending. Okay. Now bending moment at C is equal to, this is my point, right? So left side I have only one force, so I am considering this. This is upward force. This is making a, you see my cursor, this is, because of this, the beam will tend to rotate in clockwise direction. Left side clockwise, so it is positive. So the bending moment will be RA into the distance 2.5. Now RA I have already calculated as 11.41 into 2.5. What is this? 11.41 into 2.5. So it is 28. Just copy and paste here. 525 kilonewton meter. So that is the bending moment at point C. Now at point D, BMD is equal to, I will take the right side force. Left side I have too many things. You can do it. If you want, you can check it out. You will get the same answer because this is how I have calculated the reactions by taking the condition summation of all the forces equal to 0, summation of all the bending moment is equal to 0. So you will get the same answer. You have to get the same answer. Now I am taking right side RB into perpendicular distance is 1 meter, right? This is at point D. Now this is on the right side of D and it is upward, because of which it is making a counterclockwise movement. So right side counterclockwise is positive, so the sign is fine. So this will be equal to B, which is 14.59 into 1. So that will be 14.59 kilonewton meter. Fine. Now I have the bending moment at all the salient points. I can draw the BMD. But there is a catch. I will tell you what is that. So for drawing the BMD, you draw a horizontal line first. Now at A and B, the BM is 0. So I will just write that this is 0 and this is also 0, correct? Then at C and D, it is 28.525 and 14.59. So I will just mark these first. let us say here it is representing 28, and here this is representing 14.59. 14 into 2 is 28, so it is around midway of this, right? Now come back to the force diagram. Between A and C, there are no forces, correct? So you just join by straight lines. So this is 0 and this is, and between D and B, there are no forces. So I will join by straight line. Now what about this? Should I join by a straight line here? No, because I have a UDL in this section, right? So a uniformly distributed load will have the BMD which is in the shape of a parabola. It's a parabolic curve, right? Now, to draw the parabola, I need to first know where is the maximum bending moment so that I can shape the parabola properly. Correct. We have studied earlier that the point where shear force is equal to 0 and it is changing the sign from positive to negative or negative to positive, the maximum bending moment occurs at this location. So this is the location at which maximum bending moment occurs. So I'll first have to find this location. So for this, what I will do is I will do another construction. I'll draw a horizontal line like this first from this intersection point. Now I have two triangles here. You can see this is one triangle and this is another triangle. I'll name this triangle. I'll call this as X, I'll call this point as Y, and this as Z, and I'll call this as P, Q, and R. Okay. Now from this triangle, the angle XYZ and angle RQP, this angle and this angle is equal. It is alternate angle. This is a horizontal line and this is a vertical line and this is vertical line. So this angle XZY and PRQ is 90 degree. These two are 90 degree, and this line is a common line. XY and QP is a common side of the triangle. So I can say this triangle is similar to this triangle. Now using the similar triangle concept, I will have to find the length ZY, which will give me the position of maximum bending moment, right? So I will write like this. From triangle XYZ and PQR, we have, I need this ZY and QR, right? So I will write ZY by QR is equal to ZX by RP, and this is equal to the inclined line XY by PQ, correct? Now amongst this, So this inclined length, I can find it, but it is very complex. So I can skip this. I can eliminate this. This is easy to use, right? So I will, from this I can find, I need basically zy, so I can easily find that, right? Now zy, I will call it as, oh my god, meeting is going to end in 5 minutes. All of you please put your roll numbers. Now zy, basically I'll call it as, I need to find that, right? So I will write like this: zy by QR, right? So QR is actually 4.5 minus zy. 4.5 minus zy, and this is equal to zx. Now zx is 1.41, right? This is 11.41 minus 10, so this height is 1.41, and this is 7.59. So by 7.59. So if you solve this, you will get zy. So zy is equal to what? Now let me first calculate this. 1.41. Anyone has a calculator can quickly do this? Because in this it will take time. Where is my answer? I have it here. Let me try this. This is the old one. I cannot do. Anyone has calci? Okay, you can solve this later. I will give the answer. This xy comes as 0.7 meter because my meeting is ending, so I need to finish quickly. So I need to now find the maximum bending moment at this point. I'll call that point as y. Right here. Now BMY is equal to, I have the point here, right? So I'll start from this side. So this is RA into 2.5 plus 0.7. 2.5 plus 0.7 is 3.2, right? So 3.2 meter. This is downward, so minus 10 into zero point 0.7 into 0.7 minus, then I have UDL for 0.7. So I'm directly doing this 2 into 0.7 into 0.7 by 2. So it is 0.49 minus 0.49. So this will be, and RA value is 11.41. 11.41 into 3.2 minus 10 into 0.7 minus 0.49. So it is 29.2. That is the maximum bending moment, right? So here I have 28 point something. So slightly above this, you will have the maximum bending moment. So you just have to draw a parabolic curve like this. So this is the maximum bending moment. Quickly, please enter the roll numbers because the meeting is going to end. Any doubts or question in this?
No, sir.
Everyone has understood?
No, sir.
Not understood?
Yes, sir. Understood, sir.
Fine. Next class, if you want, we can again